Good morning all. I'm sorry to participate remotely. I would prefer to be you, but because of pandemic, I'm obligated to make the pre-recording. My name is Dalu Diken in collaboration with Fabrice and Laurent. The presentation focus on big data for monitoring mobile application. First all, I'm research from University of Douala in the Applied Computer Science Laboratory in collaboration with the Algorithmic Complexity and Logic Laboratory of the University of Paris-Créteil. Your all center of interest are the mobility and communication system, more precisely the interoperability between network, big data, intelligence artificial, parameterization, and IoT. The plan has six essential points: introduction on the supervision on anomaly detection, log analysis and reporting on artificial intelligence, user case for the anomaly prediction, the present software architecture and data streaming, the artificial intelligence model and result, finally, and conclusion and some perspective. With multiple sources of information, the supervision of mobile applications become essential and require administration of the different applications. We want to detect anomaly by information visualization of event fraudulous action. In order to have this information, developers use the log application programming interface to transmit all behavior data. Log message play a key role in several phases, not only the runtime, but also in all the test phase, unit, integration, system, and functional. Your effort in focus of the analysis of log message in use. The difficulty associated with log analysis relate first to the volume of message received, and then it grows rapidly with the number of sources. And second difficulty arises with the flow of the message will depend on the use to the monitoring application. Finally, it's not uncommon for large embedding application to have its word log format even is generated by the same API. In this case, it's necessary to consider a standardization of format during the collect in order to be able to extract information from different sources and put them in causal relation. All these properties like to the processing of log message naturally leads up to consider this work as a big data workflow applied to the timescape. Predictive log analysis is Winderlin student topic. Part of the work focus on ensuring the information itself, and second part concern the use of this data to react, alert, and more generate automated process. The development of machine learning has greatly impacted the use of log, depending on the work student lean to the detection of anomaly or the discovering of software attack. On the use of predictive machine learning model, we have Adam Oliver and log analysis model, Luke and rulebook for aid model development, Anderson and Steven for reporting, Dos Santos and reproductive analysis approach. In the use case for the anomaly prediction, in the context of description, we define an analysis of an experiment in laboratory. In biology training, many experiments are done where students are asked to prepare, perform, and follow up. In this context, mobile devices are provided to take picture, record sound, or even use the different sensor to collect data. From the recording on the different document in the memory of the mobile device, and software suite is installed. It allows the authentication of the user, the dating of each collect information, and the transfer at the end and the experiment to a server for validation. The principle and nominal scenario during an experiment in lab room, we have student, mobile app, teacher, lab session, storage server. To illustrate your network architecture, we show infrastructure mode. We observe the nominal scenario during an experiment in lab room. If the software architecture of business path is very simple, it's not only the entry point of the information collection, we gather the log data on the storage server. This analysis of log is more complex. The arrival of log data continues, the need to impose a data schema to index the information, refine the search for information and detection of anomaly. Your goal is to collect and cross-reference information from the various sources. This is essential to monitor the event related to the management of the laboratory section. In addition, any event related to an information capture or modification is useful. The server application pass is deployment of the storage server. The component is so what in Java content the implementation of web service allowing or the loan are to receive the document and student. This pass is deployed with the Spring Boot library. You use intensive the Spring configuration from the log, but also for the persistence aspects. The database is PostgreSQL version 10. We focus on describing your big data workflow for collect to building your AI model. In big data architecture, you have data collection and big data analysis. This figure shows the rollout component of your project. Deployment on the lab-run platform. We develop Kafka for topic partition, farmer root, consumer, database is Jasper Resport, and IAD model. In data streaming path, your component called Spark SQL Consumer contains a Kafka receiver class. Will run and execute as a long runner stack. Each receiver is responsive for handling on input discrete stream. Spark SQL consumer component and to apply name convention and common structure. We have defined a mapping between HBase and Spark table called table catalog. The HBase sim explores the parallelism on the set of region server. The pipeline is run with Apache Spark and Apache Spark Sol connector. Spark framework is used from distributed in memory, compute, transform, and inject to burn the pipeline. The Apache Sol collection will play the role of SQL table in configuring shard. The definition of a shard is based on the number of partitions and the replicate rate from fault tolerance ability. The Spark executor runs the entire with transform and enrich each log message. Sol Cloud and a data source Spark in use when we create your machine learning model. We send record for Spark machine learning class and read result from Sol with the use of Sol resilience distributed dataset. With Spark SQL, we expose the result on SQL table in the Spark session. These data frames are the base of your machine learning model construction. The metrical, term factor, and inverse document frequency are key features for the machine learning model. The concept behind SVN algorithms are relatively simple. They classify separate data points using hyperplane with a large amount of magic. In your working context, the magic between log pattern is suitable discriminate. SVN offers very high accuracy compared to other classifiers, so as logic regression and string. Data features are measured obtained from Spark SVN model. The analytical expression of the feature precision, recall of retrieve log messages that are relevant to the fund, precision in the fraction of retrieve log messages that are relevant to the fund, recall in the fraction of log messages that are relevant to the squaring that are successfully received, and runtime for your dataset based on unique log format. The cost of Spark SQL consumer decreases where the partition of dataset increases as illustrated in figure. The x-axis represents the partition number and the y-axis represents the time consumer. We have to oversize the partition and the gain are most less. In this table, we have 4 classes, and for each class we compute 3 numbers: true positive, false positive, and false negative. For instance, for this class, we note these numbers TP3, FP3, and FN3. For this value, we compute precision by label, recall by label, and FX score by label. We are result from 4 classes and within acceptable range of value from the use of the model to be accepted. However, your results suggest to increase the number of log patterns deteriorate the performance. In conclusion, your approach on log analysis and maintenance tag prediction, we showed an index engine is crucial for the shiftable query engine. You have developed a specific plugin. You have addressed the key role of your Spark complement, one per data source. You observe that your approach supported a large volume of log. From the filter log, we present the construction of your SVN model based on work from the Center for Pattern Recognition and Data Analysis. Your student also show the limit that we want to put back so at the management for log. In perspective, we like improvement of the indexing process based on consumer schema, dynamic extraction of the log format intense of the use of static definition, management of malicious message of pattern. For the design of your PowerPoint, we use for reference. Thank you for your attention.